for today's session. Your phone line has been automatically muted, so please do not unmute your line. All right, so with that, again, thank you so much, everyone, for joining us today. I'm going to switch things over to Doug Ming, who is going to share his camera. We'll ask that you all do not share your cameras because that will cause a disruption for everyone. And Doug, you can share your screen and your PowerPoint. And I must say, before Doug gets started here, we are very, very lucky to have Doug with us today. He's an extremely busy scientist who's been working on Mars, as you will hear, for quite some time. And it is my pleasure to introduce to all of you Doug Ming. And again, if you have shared your camera, we'll ask you to unshare only so that it doesn't cause any technical difficulties for anyone else. So, Doug, thanks for joining us, and I'll turn it over to you.
Thank you, Paige. And thank you, all you students and teachers out there, for coming to Johnson Space Center through this webinar today. I know you all got very busy schedules, and I do thank you for taking your time to come hear a story that I hope to tell you about sending humans to Mars. Before we get started, I just want to let you all know my position. I am the Chief Scientist for the Astromaterials Research and Exploration Science Division here at the Johnson Space Center. My primary job is to make sure that that I lead the science activities of our division and look forward to the future. What do we need to be doing for science at other planetary surfaces, and Mars is, of course, one of those key surfaces that I am working on the most these days. So I want to back up and just very briefly let you all know about how I got to my position today. Why is somebody from a little bitty town in eastern Colorado here at the Johnson Space Center help leading the nation's science activities for the space agency? Now, I was born in eastern Colorado. I grew up in a little town called Ray, and Ray's a really small town. It's mainly an agricultural area, so I grew up on farmland, learning basically the chores of being a farmer ranch hand. We were growing sugar beets and wheat and corn, along with raising cattle. So that really explored me to the agricultural side of our great nation. I was fortunate enough to do pretty well in grades, so remember that. You have to do well in grades to go on to college. And so I traveled to Colorado State University in Fort Collins, Colorado, where I received my bachelor's degree in agronomy. Now, if you don't know what agronomy is, and most people do not, it's the study of soils and plants, primarily for agricultural purposes. And that is, can we grow better crops? Can we make them much more efficient in providing food for not only humans but also for animals, such as we were doing in eastern Colorado, primarily for cattle. I then had the opportunity, again, did pretty well in my college undergraduate, to get invited to go on for a master's degree at Colorado State. So I did that, graduated, and I asked my major professor what he recommended, and he said, now that you are this far along in your education, I highly recommend a doctorate degree, in this case, soil science. So I asked him where to go, and he recommended that I travel to Texas A&M University here in the great state of Texas. And that's where I received my doctorate degree back in quite a few years ago, 1985. Now, while I was there my last year, I was really fortunate. This is where I was in the right place at the right time. Two scientists from NASA were visiting that day, and they were asking, could we grow plants on the moon? And this really sparked an interest in me. I've always been excited about space exploration. I was glued to the television set and the radios back in my day, listening to the Apollo missions where we landed humans on the moon. Incredibly exciting times, and that really did excite me. So I wrote a proposal to NASA. They accepted that proposal, and I started at the Johnson Space Center back in 1986, first as what we call a postdoctoral fellow, where I did 2 years of research, and then I was fortunate enough to get hired on by NASA. And so I've been working for NASA for the past 30 years as a government employee. Now, I have a lot of exciting things I've done through my career, and one of those that I really love is that I have the opportunity to lead operations for our current rover, Curiosity. I've been involved in other Mars missions, the Mars Exploration Rovers Spirit and Opportunity, and oh, by the way, Opportunity is still operating this very day, nearly 14 years after Opportunity landed on the red planet. I've been involved also in the Mars Phoenix Scout mission, where we landed near the northern polar region on Mars. So, you know, ask yourself, somebody has to drive these rovers on Mars. Why can't it be you? And that's what I ask myself, why can it not be me? Somebody has to do this, and one thing it does take, though, is a good, solid education. Of course, that means you have to do those wonderful classes of math and science there at your schools. Now, one thing that has happened with all these missions, it's really changed the way we have looked at the red planet. These are some of the missions I was talking about. I've been involved in the ones on the top here, the Mars Exploration Rover Spirit and Opportunity, the Mars Phoenix Scout, where we landed about 68 degrees northern latitude on Mars, pretty close to the Mars polar cap. Then Curiosity, the Mars Science Laboratory, and then we have a host of orbiters that are now circling the planet, giving us information about the mineralogy, the chemistry, as well as the morphology, the geology of the surface of Mars. Now, Mars, it has been a fascination of humankind for as long as we know, the red dot in the sky. So now my first question to you all out there is, why is Mars red? And if you would put your answer in the chat window, we'll take a look in a moment.
So as you're discussing that and putting your answers in, if you are sharing your camera, please do not share your camera. It's unfair to the other schools, and it could cause problems for the rest of the session. So please stop using your camera if you are, but do put your answers in the chat window to Doug's question, why is Mars red? So Anasazi is saying it's red because of the chemistry of the planet, the iron, the dust, the dirt, and Anasazi is in Arizona. Vintage Magnet from California saying Mars is red because of the rust on the surface. Let's see what other answers we're getting. Also, the New Mexico Museum of Space History is mentioning iron oxide. We'll see if we get any other answers. Trico Elementary from Illinois, I believe. The minerals in the soil cause oxidation and rust. So we're getting some really interesting answers, and we have a few groups from Trico and a few from Anasazi, and of course the Vintage Magnet. So Doug, one moment, please. Por favor, si están compartir su cámara, favor de dejar de usar su cámara. No podemos permitir eso, por favor. Trico Elementary adds in iron in the soil and the atmosphere. So, Doug, pardon my interruptions with some of my other messages to groups, but what do you think of some of these answers here?
Well, if we were taking a test right now, you would all get a passing grade with flying colors. And yes, Mars is red because of rust. Rust is nothing more than good old iron metal, and if you see an old jalopy setting out in the elements for long periods of time, it will begin to rust. And this is this iron, this metal iron, oxidizing to this red color. So well done on your answers on that one. Okay, now, here in Texas, everything is bigger, right? Well, guess what? Mars has a lot bigger land features than anybody could ever dream of. In Texas, we have a valley on Mars that, if it was in the United States, it would stretch from the east coast of the United States to the west coast of the United States. That is a big canyon. We also have the largest volcano in the solar system that we're aware of, and this is called Olympus Mons. Olympus Mons is almost 3 times higher than the highest volcano on Earth. So that gives you an idea of how big these features are on Mars. Now, one thing that we have to deal with when we send humans to Mars is probably dust. Now, here you see 2 images. On the left is an image taken by the Hubble Space Telescope back on June 26th of 2001. Then my colleagues took another picture a few months later on September 4th, 2001, and you can see how it's just totally looks to be covered and hazy, and this is because of a global dust storm. The entire surface of Mars is a raging dust storm. So this is one thing we're going to have to deal with when we go to Mars is the dust. And here is our series of images taken by a camera on board the Opportunity lander. And you can see on the very left that it has a pretty hazy, you can just barely see the light through this. And as we went on in time, the dust storm got worse, and it got to the point where almost no light was getting through to the Opportunity rover. We also have dust storms. These are dust devils that were taken by Spirit in Gusev Crater, and you can see that they look just like dust devils we would see here in the United States, particularly those of you that live in New Mexico, out in the western part of the United States. You're more likely to see these than you would probably somewhere back in the southeast. So here's a question for you. Here is two pictures, Opportunity right after it landed, then Opportunity some years later, and you can see the dust covering the spacecraft. So what problems could dust cause for human missions? And please put your answers in the chat window.
So we're going to stand by and see what you come up with for the problems dust could cause. So right away we're getting some damage to breathing, vital systems such as life support from the Museum of Space History in New Mexico. We'll see what else we get out there. Equipment covered in dust, also from our New Mexico group. Gulliver in Florida saying breathing, visibility, damage to hardware and machinery. Anastasia in Arizona is mentioning that dust can cover equipment, blocks the signal, and damage that equipment as well as the human body. Trico Elementary, our group in Illinois, says it could affect your breathing and could clog up all your equipment. It could also cover up, good observation here, the solar panels. Anastasia adds damage to spacesuits, getting into the equipment, difficulty seeing landing spots, and difficulty receiving light and seeing things from the surface, or even engine damage. So we have some well-thought-out answers. Even Vintage Magnet from California adds in it could cause problems to human missions for vision and movement. And again, this whole idea that dust could get and cause some malfunctions. Well-thought-out answers. What do you think, Doug?
I think they're great answers. And you're almost nailed every single one of the ones, and even some more that I have here on my list of what we think are some of the more important aspects of this dust. NASA views this as a potentially big problem. We are having a dust workshop this summer, bringing together the experts at NASA, universities, and also across the world from our international partners to talk about dust and how it might impact humans on Mars. One of the big ones is potential toxicity to humans. There might be something in that dust that might actually react with the lungs and cause some, maybe some serious health issues. That's one thing we got to address, because dust will almost certainly get into our habitats because seals just don't necessarily keep out all that dust, and that will be a major problem. And I know that one of the groups here answered seals. And dust on the solar panels. You can see here on Opportunity that Opportunity is pretty well covered. That really impacts the amount of light from the sun hitting those solar panels and does affect our power. So that's a big one. And you were talking about things blocking our vision. Absolutely. Dust on the cameras. You can't see very far. This is a real problem. And then we have all kinds of moving parts, machinery, these kinds of things. And dust getting in there, as you know, if it gets dirty, it doesn't work quite as well. So these are real issues that we'll have to deal with when we go to Mars. Okay, now the next thing is, think now if you go to Mars, what will you need to survive? What are the essential things that will keep you alive on that planet?
All right, so in the chat window, we'll see what comes up here from our groups around the nation and what they get. So stand by for some answers. So we get from Gulliver food, oxygen, water, essential nutrients, food, air, and water. Let's see, and that's from our New Mexico group. We get water, oxygen, food, spacesuits, plants to give you oxygen, suits to keep the dust away, some kind of airtight habitat from Trico Elementary. Vintage magnet adds in that we would need water, shelter from the dust and heavy winds, oxygen, and food. Trico adds in from Illinois, you need food, water, oxygen, light, and warmth. I have to tell you, Doug, the full responses that we have here from these groups, I can only imagine what's going on in their classrooms as they're discussing this and getting this input into the chat window. So we've got some distinct answers here. What do you think about this?
Absolutely. I'm the one that just summed it up. You need food, water, oxygen, light, and warmth, and those are the main things I have on my list. You need water, of course. You need breathable air. You need to have that atmosphere like good old planet Earth. Food, you got to have food, right? And the shelter to keep us warm and the power to maintain that system. So you got it. You nailed the basics. Now, NASA's been working on this for a long time. We know this is incredibly important when we send humans anywhere, even to the International Space Station. We have to have these particular elements to keep those astronauts alive. So we have been working on areas that we call air revitalization, converting that carbon dioxide we breathe out back into oxygen, wastewater reclamation. You got to take all that water that you put on there and you have to turn that back into potable water so that we can reuse it. And of course, food. There's no question we need food. And then solid waste. We're going to have to treat the solid waste, and on a planetary surface like Mars, we're looking at ways that we could totally reuse that the solid waste back into the system, recycle it, regenerate it. And then you're going to be in this closed can, and you're going to have to worry about outgassing of materials. So this is an area we are very concerned about. Make sure that we don't have any kind of trace contaminants that might be detrimental to the crew. So what are we trying to do? We're trying to create what good old planet Earth does for us inside a tin can. This is really a challenging thing to do. So we are working on these systems and trying to look at various ways to do that, and one way is to try to recreate what we do here on Earth. We call these, NASA talk, bioregenerative life support systems, where we use living systems and also physical systems like brute power and force, like electrical power, to convert all these different essential things we need to live on this planet. For example, you could have plants that are producing, where do plants produce? Oxygen, right? That is incredible for us. And then they take that CO2 through light, a process we call photosynthesis, and utilize that in making their biomass. But we could see this as one large recycling can on the surface of Mars. That's how I see that we will do it. Okay, now we've talked a little bit about some of the challenges. Okay, just for what do you think are some of the other things we might have to think about? You know, we've thought about the essentials. What else?
So here in the chat window, thinking about the biggest challenge for a human living and working on Mars. So let's see what we come up with here from folks, some of the biggest challenges.
Now, I'll just give you a hint here on this one. Think about if, you know, we know food production is important. How would you do that? How would you grow plants?
We'll see what we come up with here, standing by. So Gulliver says psychological effects. Thinking a little outside the box there. Communication with Earth, planting and harvesting seasons, and medical from the New Mexico Museum of Space History. Let's see what else we get. Delay in communication from Gulliver in Florida is another possible challenge that we'd have to deal with. Let's see what else we have coming in. Anastasia from Arizona says to keep the spacesuit on all the time and keeping up with the supplies necessary to live. Now, Trico Elementary in Illinois brings up a really interesting point of recreational activities and the challenges to maintain, let's see, to maintain the shelter, airlocks, sleeping, maintaining supplies, waste issues. Vintage Magnet is also mentioning sustainable food supply, dust, and the concern of mechanical breakdown. Also, Trico adds in communication systems, transportation, games, recreation, getting homesick for your families. Gulliver adds in another possibility of radiation. Wow, again, thorough answers. And Vintage Magnet adds in temperature extremes as well as communication. Quite a few challenges there.
Well, I tell you what, so it's incredible. When we work together as a team, we come up with what we need to do in order to live on Mars. And the group of you just now came up with the major things that NASA has to work on and is working on to send humans to Mars. So what does that tell you? That it's together as a team, we came up with what needs to be done, and now we need to work together as a team in order to make sure that happens so we can get humans to Mars. So now the one thing that I was going to poke at just a bit is one important challenge is growing plants. We can do that by several different means. We can actually use soils from Mars, maybe bring them inside the habitat and grow our plants. Another one is we could use water. It's called hydroponics, where we can grow plants in the water to produce our food. So the next question I'm going to ask you is a really important one. If we are going to grow plants, the necessary elements and nutrients required for plant growth have to be available. Can you give me those various nutrients?
So let's see this team and what they come up with as their nutrients essential for plant growth. I love this question because it really is interesting to see what we come up with and awaiting some responses. Gulliver saying NPK, growing medium water LED lights. Trico says water, sunlight, and minerals. Anasazi, water, soil, light source, air. Now be specific as far as the nutrients if you know any. New Mexico Museum of Space History includes water, iron, they think, possibly, and the sun. Vintage Magnet mentions water. Our Technica 2 group says water, soil, and light. Any other nutrients? And we heard NPK, which was very interesting. Anasazi mentioned sunlight, H2O, and nutrients, light, proteins, vitamins, water, carbon dioxide, pollination, soil enrichment. So now some of our groups here today, Doug, are some 4th and 5th graders, all the way up into some high schools and adults, but some of our younger students, they might not have gotten into some of the specifics of this. So
probably not.
What do we need? Yeah. Gulliver is mentioning calcium, magnesium, sulfur. So we're starting to get some different answers there. What do you think, Doug?
Well, you got all the major and secondary nutrients and elements that plants need. And this last one, calcium and sulfur and magnesium, are what we call the secondary nutrients. They're really prime. So here we go. Here are the 16 essential elements that we will have to have on Mars. Of course, you got the carbon and the oxygen from the carbon dioxide. The water has hydrogen and oxygen. And you nailed the nitrogen, phosphorus, and potassium, and you got the calcium, magnesium, and sulfur. So you nailed the micronutrients. And you've also got some of the macronutrients, but you also got some of these micronutrients correct. Iron, that is something you need in small amounts, but plants have to have it. Now, this is probably, you won't get into this too much until maybe you get into college, but these are things, if you're gardening, that you might have to add to your garden in order to maintain the health of the plant. Zinc, molybdenum, manganese, copper, boron, and chlorine. Those are the 16 essential elements necessary for plants. Now, one thing I want to point out, all 16 of these elements are on the surface of Mars. So now we might have to take some fertilizer with us. We might have to take a little nitrogen because the nitrogen in Mars materials is really small, but at least we know that Mars has all of the essential elements for plants, which is good for us if we go there and live there. Okay, now the big one that many of you mentioned is water, right? Water. So the question is, look at this. This looks really dry on Mars. You don't see any lakes, rivers. You don't see any water on the surface. So if we go to Mars, where will we get our water?
And that is a view from the Curiosity rover. Is that correct?
That is correct. That's looking into an ancient lake bottom by Curiosity rover in Gale Crater.
Awesome. So this dry-looking place, we're going to get water from maybe subsurface water, under the surface, recycled waste, as they do on the International Space Station, perhaps. Condensed it from the atmosphere comes from our group in Illinois, Trico Elementary. Underground wells, possibly. Technica 2, our group from Mexico, mentions to possibly drill under the surface. Trico mentions the polar ice cap. Vintage Magnet also alludes to this whole idea of recycled waste, or melt any ice that may be on Mars. And Gulliver seconds that, melt it from the ice. Vintage in California mentions this drilling aspect, as did our Mexico group. And Anasazi from Arizona says, dig deep under the surface, plants that provide some type of water, like maybe even a cactus. Some of our Anasazi groups in Arizona might be familiar with that. And digging wells and melting ice caps. Some new answers I have not seen before.
Yeah, outstanding. I'll never forget one time a student calling me and wanting to give me their ideas about growing cactus on Mars, which is not that crazy of an idea. It's really dry. Cactus can survive there. It is pretty cold, so the cactus is going to have a challenge, no doubt about it. Yeah, you nailed most of the answers that I was looking for, but before I get into answering some of the areas that NASA may look for water, I want to give you a few facts about Mars, about the climate on the surface. Temperatures. Boy, you were all talking about cold. It is really cold on Mars, minus 225 degrees Fahrenheit. Whoa, if you were exposed to that for just split seconds, you would probably freeze solid. However, at the equator, during the middle of the summer, and by the way, Mars has seasons just like Earth, winter, summer, fall, and spring. So we have the same seasons on Mars. And at the summer, it can get up to just probably the same temperature as inside your room right now, your classroom, about 70 degrees Fahrenheit. Now, one thing about Mars, Mars has a very, very, let's say, very low amount of pressure, and it has a really sparse atmosphere. And it's 1% as thick as here on Earth. So that's a lot different, and it's primarily composed of carbon dioxide. So because of that, it doesn't hold heat very well. So it has huge cycles of temperatures from daytime to nighttime, and you can see that it can go as low as 225 degrees and maybe as high as room temperature in just a single day. So it's really large because of that. Now, the one thing is that you got it. There is water on Mars, and the polar region, we know there's water because we can look at it from our Earth-based telescopes and see that liquid water frozen at the surface. Now, there is also water that is just, some of you are talking about going to the ice just down under the ground. Well, we landed near 68 degrees northern latitude on Phoenix, and when we were landing, we blew away the surface material, the loose material on the top we call soil, and exposed the ice. So what you see underneath the lander here is big slabs of ice. So we could mine that. And we know there's been a lot of water. There looks like this is a channel flowing into a crater that could have been an ancient lake. So your questions or your answers about subsurface water is a good one. We don't know how far to go, but there should be water somewhere underneath the surface. And we know these ancient lakes were probably, at one time, thriving water on the surface, and then it's probably receded subsurface, it's probably evaporated, it's probably gone to the poles, and also we know that maybe some of that water has escaped into space. So it could have been lost over the last 3 billion years. These are some of these ancient lake sediments that we have looked at on the Curiosity rover, And the reason we know that, they are in layers. These are what we call sedimentary deposits because they've been transported, these little grains and sand and silt and clay, and they're deposited, and they deposit in layers. We call them sedimentary rocks, and these are in such a position, and the angle that they dip towards this big mound in the middle of Mount Sharp called in the middle of the crater called Mount Sharp, we know that this is probably deposited in a lake and a delta, maybe like a delta like you see along the Gulf Coast. Also, we know water is tied up in the regolith, the soils, and the bedrock right there at the surface. The Curiosity rover has an instrument that takes sample, puts it in an oven, heats that material up, and as it heats it up, it dries off quite a bit of water, about 2 weight % water. So you got almost every one of these. Where will we find water? Polar caps, permafrost, layers of ice underneath, extract water from the soils, also maybe salt brines if they exist on Mars. There's some hypothesis that there might be salt in some of these materials we see. And then also from the atmosphere, although you remember the atmosphere on Mars is only 1% as thick as Earth, and it has very little water in it. So it'd be tough to get a lot of water out of there. Okay, here's an easy truth. This is just a select the correct answer. What else will we need to survive on Mars? Protection from radiation, protection from Mars environment, production plants for resources, in other words, producing oxygen and water, or all the above? What's your question? What's your answer?
So we're immediately getting from all schools that we have on the line, D, all, and you're absolutely right, Doug, in thinking that this was going to be an easy question because we have from all groups, Illinois, Arizona, California, Mexico, Florida, they all say D.
Yep, you got it. You passed again. So, yes, we are going to have to deal with these radiation. Here on planet Earth, we have these wonderful magnetic fields around the planet. And because those fields are around the planet, they deflect a lot of the solar radiation. That little bit of UV gets through and gets down and we get sunburn. But on Mars, it is really serious because if Mars does not have this kind of a field around it, and it allows the radiation to just hit the surface. So we are going to have to deal with radiation. We're going to have to protect the crew from the stark rays of sunlight hitting the surface of Mars. And also we're going to need protection from the environment. Those of you that may have seen the movie The Martian, that was a pretty good movie. It was pretty factual in most cases, and the types of suits that they were using on The Martian are real similar to the types of suits that NASA has created for Mars explorers. We are working on these. You see the rover here that was used in The Martian. Here is one of NASA's rovers that we hope to someday send to the surface of Mars. So we're working on these various items, and you have to have a space suit to protect you from the elements of Mars, and you have to have a habitat if you get out of that spacesuit to protect you. And that's one way to do it is in the confines of a vehicle. We're also working on outposts. You recall that on the Martian they had this nice large outpost area, and we anticipate the same thing on Mars, where we have an outpost on the surface that will allow the crew to work in a shirt sleeve weather environment so they don't have to be in that spacesuit all the time. And production plants are going to be really important. Here we're going to have to produce the oxygen to give to our crew. We might also produce oxygen for propulsion systems where we'll use it for rocket fuel. We'll have to get some way to extract the water. Maybe we'll heat the soils up, so we have to have a production plant to heat those soils up, produce that water, or maybe we'll drill down into ice, like some of you have suggested we do, and extract that water. But no matter how you do it, you're going to have a plant there in order to process large amounts for a crew of, let's say, 4, 5, 10 people. You can well imagine if there's that many there, it's going to take a fairly sizable amount of pilot plants in order to do that. So I'm just going to finish up here with the one thing that I think you have realized today, working together, all the schools that are involved in this webinar, you have pretty much defined what NASA is working on to send humans to Mars. And we do hope to send humans to Mars in the mid-2030s. And so working together as a team, just here as we do at NASA, is absolutely essential, just as you have worked as a team today, to answer these questions that I have asked. Now, the one thing I want to just try to illustrate to you all, you don't have to be an astronaut to be involved working for NASA. We need all kinds of folks with different backgrounds. And if you recall, we were talking about that production of food. Well, what are you going to need as far as people goes to enable that? You need farmers. So you're going to need farmers, historians, medical doctors. Absolutely going to have a medical doctor on our trip. So you're going to have somebody associated with keeping the astronauts healthy, lawyers, technicians, and of course the main folks that will help build these various components of a Mars base are the engineers and the scientists and the computer scientists. But regardless, a solid education is needed in order to be involved in this great work that we're going to do to send humans to Mars. So think about this. 2030s is when we're going to send humans to Mars, and guess what? I'm getting pretty old, and I probably won't be able to go to Mars. So the absolute perfect age for folks that will go to Mars are those of you that are sitting in your classroom right now. So you will be the ones going to Mars. So the question you have to ask yourself, do I want to get involved? And the first thing is, you're going to have a really good education in order to do that, but will you be the first geologist, the engineer, the physician to go to Mars? It's going to take a whole lot of people to do that, not just the folks going to Mars, but the folks building the systems to help enable going to Mars. So the one thing I want to end with, I always like to brag on my college roommate. He was from a little small town in southern Colorado, a little town called Del Norte, and we were college roommates at Colorado State for 3 years. And he came in his final year there at school, and he said he was going to go join the Navy, which I found somewhat surprising then. But it just so happens he had gotten a civil engineering degree and was a phenomenal student, so it surprised me that he wanted to go join the Navy. And the main reason is he wanted to fly jets. So he did join the Navy, went off and flew jets. And he was trained to land on aircraft carriers out in the ocean. So he went and did that for quite a while. And then we stayed in contact, and we got together from time to time, and he was telling me that they had sent him to this test pilot school down in Southern California. And here they would test their skills along with test pilots that were there training at this particular airfield, and he was the #1 student. Now, this was well before the show Top Gun, which some of you may have seen, but he was the #1 pilot. He called me up not too long after that and said he was coming down to Houston, Texas to talk to the folks at NASA. And I said, oh, wow, why? And he said, well, they're wanting to know if I want to look into the astronaut corps. And so he was going to go down there and check into that. He decided to apply for the astronaut corps, and just to let you know, my old college roommate from a little town in southern Colorado flew into space 5 times, 2 times as the commander to the International Space Station to build the space station, and then he was, subsequent to that, head of the astronaut corps for about 5 years. So you can come from really small places on this planet and do really big things. I look at my college roommate, what I've done from being out in eastern Colorado in a little bitty town. It just all matters on getting that education and getting on to school so that you can get that education to get to these types of positions. So with that, Paige, I think I'm going to turn it back over to you, and we can then address any questions the students may have.
Awesome. Well, thank you so much, Doug, for not only sharing your expertise, but for reinforcing to all those students out there, you never know what your future holds for you, whether you come from a small town, a big city, a suburban area. anything is possible if you put your mind to it. And so Doug's roommate, as well as Doug himself, and look around your area at yourself and those around you. One of you just might be giving a presentation in the future from NASA or even flying yourself to Mars. So great, great story, Doug, and thank you so much for sharing that. Now, for those of you still on the line, and I think we do have the majority of our folks still here, we've got a good amount of time for you to ask questions of Doug based on some of the things you learned today, some of the other things you're curious about. So here's your chance to write your questions in the chat window, and then we'll see what kind of answers Doug can provide to you. Now, Anasazi in Scottsdale, Arizona, is wondering how long would it take to build some type of shuttle or spacecraft to be able to go to Mars? That's a great question, Doug.
That is an outstanding question. At one time, those of you recall we had the space shuttle, and the space shuttle allowed us to launch 7 astronauts into space to go to what we call low Earth orbit, which is only up there about 120 to 150 miles, 200 miles at the most, above the Earth. And that's all the further the space station, or the shuttle, could go. Since then, we have been working on, NASA has been working on what's called the Space Launch System, integrated with a capsule called the Orion capsule. So the Space Launch System is a big rocket that can lift a whole lot of payload off of planet Earth. On this capsule, we could put 4 crew members, and we can launch them way past where we did with the shuttle. We could go up clear out of Earth's gravitational field and on to the moon, and then even on further than that. So we are building that right now. Now, how long does it take? Well, it takes quite a while. We've been working on this particular system for about 4 to 5 years. And our first major test flight is not going to happen for probably about 2 more years, and that's when we'll put humans inside the Orion capsule, and we'll probably launch them out around the moon and back. But that'll be the first stage in building this quote-unquote shuttle to send the astronauts to Mars. Now, once we get to that point, we will need to have a shuttle from, let's say, the moon area. We're looking at maybe building a small assembly facility in the what we call the cislunar, somewhere around the moon, that we will integrate that shuttle to take us on to Mars. And we are now just working on concepts for that. There are a number of companies here in the United States that are working on those concepts. So hopefully in the next few years we will start beginning the development of that shuttle to take us to Mars. So it's going to take quite a few years yet. We're looking at 15, probably 20 years before that actually happens.
Great answer and great question. Now, related to that, now how long, and this comes from Vintage Magnet 28, our group in California, so, and as well as Trico Elementary. So with today's technology or the technology of the future, how long would it take to get to Mars, and how long might crews actually remain on the surface of Mars?
Yeah, great question. So the one thing about Earth and Mars and they orbit our sun is that they align with each other, where they're the closest to each other, about every 26 months. So that is really a limiting factor. You're not going to launch humans to Mars if Mars is way over here and on the other side of the sun, Earth is over there, because it just takes too long to get there. So you wait until Earth gets closest to Mars, and then you launch so that it intercepts it with the least amount of time. That's still, under our current propellants that we use, our rocket systems we use, about 7 to 10 months. Quite a while to get to Mars. Then once you get there, you then can go to the surface of Mars, and we're looking at generally somewhere around a year to a year and a half on the surface, get those folks back off the surface, back into a spaceship to bring us back to Earth, and that whole time from launch, transit, to the surface of Mars, and return is about 3 years. So it's about a 3-year commitment just to go there for one period of time.
So by the 2030s, hopefully that 3-year journey for some group of individuals will take place, and we look forward to that day as well. Now, here's a question from, let's see, from Trico Elementary, sort of related to, you know, getting humans on Mars and then being on Mars. Trico Elementary in Illinois is wondering, so what's the gravity like on Mars compared to Earth?
Yeah, great question. So here on Earth, we call it 1G, one gravitational unit, and that's the force that's working on our bodies because of the mass of this planet that's underneath of us. Mars is a little different in that it's only 1/3 the size of mass of Earth, and therefore the gravitational effects upon a human on Mars is only about 1/3 of that as here on Earth. So if you jump up on Mars and you're strong as you are right now on this planet, you're going to jump pretty high. Quite a bit higher, in fact. Same thing on the moon, although the moon has less mass, and on the moon it's 1/6 the gravity. So it's only 6 times less gravity on the moon as it is here on Earth.
Now, speaking of the moon, Doug, Anasazi, interestingly enough, is wondering why NASA's focusing so much on Mars rather than the moon. Do you have any thoughts on that you can contribute?
Yeah, absolutely. The one thing is that we work for the President of the United States, the administration branch, and they give us directions. And the last administration had given us directions to go to Mars, as did the previous one. So Mars has been a focus for quite some time. And there are some folks that say we've been to the moon, why go back to the moon? Now, I could sit here and talk about reasons you go to the moon first versus going to Mars versus the other way around where you go straight to Mars first, but it would just take too long. But just the short answer is it's really a political thing. It's the powers to be that are leading these efforts are the ones that direct it.
Very interesting. And now, somewhat related to that, so if we are focusing on Mars, one of the groups here are Vintage Magnet 28, and I have two sort of related questions. They want to know, well, if people were going to go to Mars, how many people would go? And Anasazi sort of adds to that, what would you be looking for as a landing site on Mars for this however many people that might go?
Yeah, these are questions that NASA is working on right now. We are looking at how many people you would send to Mars, and it's anywhere from 4 to 6, some say 8 on the first mission. But 4 will probably be the minimum amount that will go. So I think 4 people will go in the first one at least, but could be 6, could be 8. So that'll be discussed more and more by mission planners here at NASA to make that decision. And also, the more people you send, the bigger the mass, the more potentially the cost of this particular mission. So it could be a cost restraint as well. Now, where we will land, NASA has already identified about 50 places on the planet that we could land with humans for being that first landing site. And this is based on a couple things. Number one, you got to land safe. So you got to land in a place that's fairly flat, that you know that your spacecraft can successfully land. So that's the one key thing is what's the terrain like where you're going to be landing. The second one is science. What types of things can we do on the surface to advance our scientific knowledge of Mars? So that's the second one. And the third one is resources, the thing that we've been talking about here all morning. Is there water nearby? Can we mine that water? Can we extract oxygen? These are the kinds of things that we're asking at these various landing sites. Now, we're really early in this process. We still have quite a few years to make that decision. But once we do, it's definitely going to drive the requirements and how we build a potential spacecraft. So we'll have to do that before we get there.
Awesome. And, you know, speaking of landing sites and exploring, Vintage Magnet 28 is wondering, what about the moons of Mars? Will you explore them robotically with humans? Anything about those moons?
Yeah, so one thing that we worry about here at NASA and the government is cost. You you're all pretty probably aware, if you watch a little bit of news, that there are a lot of programs that are getting cut in costs. They're being reduced in their funding. Well, NASA's under that same budget. We are, a lot of times we are under the budgetary constraints. So one way to cut the cost down is to build a little bit smaller spacecraft that would not have to go to the surface of Mars, but that could go where? To the moons of Mars. So we could go to the moons. The gravity on those moons is very, very low, just like being in orbit around here on Earth. You would probably be almost ready, you could almost jump off of the planet if you really tried. So it could be a place we could land, we could dock, we could study those particular moons and reduce the amount of mass and the amount of cost of going to the surface. I don't favor that at all. I would prefer go straight to the surface, but if costs are prohibitive, then maybe we go visit the moons of Mars first.
Excellent. And, Lathrop High School is just wondering how many moons does Mars have, and are they similar to our moon, or are they different in some way?
Yeah, excellent question. Mars has 2 moons, Phobos and Deimos. They are very small compared to our moon, just a fraction of the size of our moon. Our moon formed by what we think is the Earth collided with a very large, maybe a comet. And there was a huge explosion. There was all kinds of gas and rocks thrown out. And the Earth came back together. And it just so happened in Earth's orbit, this big mass of materials, we call this process accretion. They came together and formed the moon. And the moon's pretty big. We think that the moons of Mars are probably asteroids that were captured by the gravitational force of Mars. So they could have just been nothing more than asteroids that were captured. They're slightly different, we think, in composition. They're really odd shaped. They're not really nice and round like we see here for the moon. So they're very different in that nature.
Excellent. Now, this might be a tough question, Doug, but Trico Elementary has asked it. They are wondering what's the estimate of the cost to go to Mars? That's a tough one.
Yeah, that's a really tough one. Let me give you some numbers of missions that have gone to Mars that are robotic. So this will give you an idea. The Curiosity rover mission that's on the surface right now costs $2.5 billion. That's a lot of money. The current mission that's being scheduled for NASA to go to Mars is in the year 2020, here just in a couple of years, and that particular mission is $2 billion. That's a lot of money. So those are robotic missions. It's not taking the human in the system and those really large spacecraft you need. So you can almost guarantee you it's going to be magnitudes higher cost than what it is right now. And I couldn't even begin to put a cost on that. But if you said no less than 20 to 30 billion, you're probably at the very lower end of a possible mission to Mars.
And space flight is expensive, and it is certainly something that helps expand our knowledge of everything from not only just Mars, but from the things that we even do or need in technology used here on Earth. So certainly many benefits.
Absolutely.
Now, speaking of curiosity, Doug, Vintage Magnet 28 is wondering how valuable has the Curiosity rover been to scientists, and what were some of the most important discoveries of this rover so far?
Yeah, Curiosity has really set our science knowledge of Mars really at a high level right now, really a high standard it's set as far as science. The biggest things is that there was running water on the surface of Mars, and it's been recorded in the rocks in the way these layers have formed in Gale Crater. We have evidence that this was a lake at one time in Gale Crater. There was water standing in Gale Crater. We're finding organic molecules in these materials. So this has given us information that back in the distant past on Mars, it could have been a habitable environment. Microorganisms could have lived in that lake, that the conditions were such. based upon our knowledge that's been gained by the Curiosity rover. So I think that's the biggest one, the biggest step forward. But it's provided a lot of other things too, the chemistry, the mineralogy, the gases. Remember I was talking about that water being tied up in the surface materials? That is only known because of Curiosity's data sets. Curiosity was the one that took those samples, heated them up, and we drove off those gases such as water, and we sniffed those with an instrument on board Curiosity.
And it is an amazing mission. Landed in 2012, is that correct?
Correct, August of 2012.
So we're going and hope to still make continued discoveries, as I'm sure we will.
Absolutely.
Now, Doug, here's a question sort of in response a little bit to one of your comments about NASA missions and such. And Gulliver from Florida is wondering, how can students and involved citizens help support these missions? How do they contact people? How do they help sort of verbalize or share their support?
Yeah, that's a great question. I think one of the best ways is through science fairs. Get your ideas out. If you got a great new method that you would like to test or some ideas, going to the science fairs is a good way to do it. Generally, those fairs are researched by university or maybe local high school science and math teachers that pass on these ideas. I'm contacted frequently by teachers about various science fair projects. We've even had one high school student that's been very active in helping select the next rover landing site for the Mars 2020 mission. So a high school student has done a lot of work in that area, presented data sets. So if you really want to do that kind of activities, it is definitely possible. You just have to be, go for it is what I say. Just got to go for it.
And encouraging you to find ways to get involved, whether it's through school, through the science fair, or through webinars like this, where the more you learn, the more you might perhaps get excited about pursuing something that you can investigate and get involved in. So don't ever hesitate to get involved and do more, because that can help open doors.
Yeah, so I can just give you some just some thoughts here. I know we have several schools from New Mexico. See, one of those is the Science Museum. In Albuquerque, they have a great educational program on Mars. One of the curators there is a scientist that works on the Mars Exploration Rover mission, works on Opportunity. And I do know they have educational experts there. So that's a place to get involved. You can really do a lot of interface with those scientists as well as give them your ideas. And I know they're very receptive to those kinds of things. So there are avenues. You just got to look around a little bit.
And even volunteering some of your time to be able to help at activities and events becomes a great way to sort of find your in. Awesome. Now, it is the top of the hour, and although we will continue and stay on the line for a bit with Doug for Q&A, for those of you that might need to depart to go on to your next class or to your next thing that you have to do there at school, I did want to take a moment here at the top of the hour to thank you for your participation and to especially make sure that we thank Doug for his participation today and sharing his expertise, his passion, and his insight. So if you do have to go, thanks so much for joining us, and hopefully we'll run another webinar sometime here in the near future. But for those of you that can stay on, we'll continue with some of our additional questions that we have here for Doug. So, Doug, you good on time with us right now?
Yeah, I'm great. And those of you who have to leave, thank you so much for joining us here today at the Johnson Space Center. And hopefully it makes you think about the future, your future. And I hope that all of you will continue on your quest for science and math, because that is key. So thank you so much.
Awesome. Thank you, Doug. And speaking of you, we had a question from Trico Elementary in Illinois, as well as Vintage Magnet, and they're somewhat related. And they're wondering, how old were you when you got started in Mars exploration? How old do people these days sort of need to be to get involved, and what's the most fascinating part of Mars to you?
Yeah, so I didn't really get thinking about Mars too much until I started working at the Johnson Space Center 32 years ago. And then I started thinking about sending humans to Mars and thinking about the red planet. But you don't have to wait until you're that old. You can do these kinds of things. And I never did a science project related to space exploration to Mars. This is something you can get involved in right now. You can do that immediately. So you don't have to just wait until some age where magically you can get involved in Mars. The decision's yours. You can get involved in Mars research, Mars exploration, whatever it is about Mars. Just knowledge about the red planet is a step forward.
Excellent. And what is your most fascinating, or what intrigues you the most about Mars?
I'm fascinated with Mars because it was once like Earth. We know there was water, there was running water, there was standing water. Could life have ever formed there? And I'm also, by training, my main background is mineralogy. I like to know what minerals are there. And Mars has a whole lot more minerals there than, let's say, the Moon. So that is really interesting scientifically to me. How did they form? A lot of those form like we do here on Earth with water. So Mars is really a fascinating place because the fact it has had so much water. The Moon has not. The Moon may have small amounts of water at the polar regions, but it's small, and there has not been water standing or running over the surface of the Moon. Mars, different.
Yeah, very, very interesting place. And I'm sure each of you have your own reason for what, or your own thoughts on what's most interesting to you. And I bet we'd get a whole lot of different answers from every person we'd ask that question to. Now, Doug, you mentioned the Mars 2020 mission. And Trico Elementary in Illinois is wondering, how long does it take to design and build a Mars rover and then get it sent off to Mars?
Yeah. So the Mars 2020 mission really got kicked off the ground about 2 to 3 years ago with the initial designs. Recently, it has gone through critical design reviews, they're called. These are where they plan everything and they said, okay, let's review what we're doing here, and that takes 2 to 3 years, and they say, okay, this looks good. Let's start spending money and let's start planning this, and now they're building. So generally about 6 years from the start of the process to the launch of that spacecraft usually takes about 6 years.
So not such a short period of time, but a lot of planning, a lot of reviews, and a lot of making sure everything is ready to go for a successful mission.
Absolutely. Now, one thing I will say is that that is the current thinking of how we do a mission. However, why not do it faster? So NASA is under a challenge these days to try to think of doing things in a shorter timeline. If you are listening to any of the news, there are some commercial space companies that are designing and turning around spacecraft very quickly. There's a company called SpaceX. SpaceX is doing things very quickly compared to NASA, and they operate very differently than NASA. So NASA needs to maybe reevaluate, can we do things in a shorter timeline?
Excellent. Now, here's somewhat of a more general Mars kind of question. You talked about Mars does have seasons just like the Earth. Now, Trico Elementary and Vintage Magnet are wondering, does Mars rotate as fast as the Earth? Is a sol, you've mentioned the word sol, is that the same thing as a day on Earth? Can you give any thoughts to that?
Yeah. Great question. I apologize for not defining the sol earlier. Mars rotates just a little bit slower than Earth. one Mars day takes about 24 hours and 40 minutes of Earth time. So that's how long it takes Mars to go around one revolution. So Earth's spinning just a little bit faster, not much, but we operate on Mars time sometimes from our operations. And what that means is that we're living on planet Earth, right? And we're going to work on planet Mars. And Mars wakes up every 24 hours, 40 minutes later with a new day, and therefore that means you go to work 40 minutes later Earth time. So that can get very challenging. You will be going to work at 8 o'clock in the morning 1 week, and a couple weeks later you're going to work at 8 o'clock at night. So it's a very challenge in that you're constantly going to work a little bit later. Now, we don't operate on Mars time for a 14-year mission like Opportunity. We did that for a short period of time, and then we started working on Earth time because it's just too challenging to us, the human physiology.
Now, Doug, did they do anything within the environment when you were working on Mars time to sort of help with the, oh my gosh, it's 3 o'clock in the morning and I'm just starting my day at work? Were there anything done to sort of help combat some of that psychological sort of thoughts on that?
Yeah, we did a little training on that, but basically it's just doing it. We had to be careful that we didn't get totally worn out by doing this. So we were very careful on not stressing ourselves out too much because you can well imagine if you're very tired and stressed, you do not want to be sending spacecraft commands in those kind of conditions. So we did some mainly psychological training. We tried to simulate day and night on Mars so that we would try to, when we're in Mars, try to keep it light when it's during the day there, and when it's dark, we try to keep it dark just to try to simulate the things that we would have on Mars.
And being well rested is so important, whether you are working with rovers on Mars or whether you're working there at school to get your good grades and get through testing and such. Being well rested is just a very important part of being able and prepared to be successful.
Right.
So, Doug, here's a question from Vintage Magnet 28, and they're wondering, in addition to Mars, is NASA thinking about other places that we might want to explore, whether we visit them with humans or robotically? Is there anything out there of interest?
Yeah, there are interest. The Saturn and Jupiter have some really interesting moons. There's a moon called Europa that has what we think maybe oceans of organics and maybe water. So that might be a place that could be habitable. So there are missions going to Europa. There's a possibility you can get a Europa lander or lands on the surface. We're finishing up right now with a mission called Cassini. Cassini is flying around the rings of Saturn, and we just had a beautiful encounter with a new moon that was in between some of the rings closest to the planet. And we're actually doing a spiral down towards the surface of Saturn, and we will crash into Saturn later this year, and that will end that mission. But it's taken data of those particular moons and new potential places we could visit someday. But the moons, I think, particularly of Jupiter, they're closer. Saturn also have very unique moons. So I think the moons of those two planets would be where we might go. Now, we can't go to Jupiter or we can't go to Saturn. They're what we call gas giants. They are monstrous planets, and the gravitational pull and the gases that are in these monsters, we would never be able to survive towards getting down towards the surface. So we could potentially visit the moon. So that's one thing we might look at doing. But that's a long ways away. I don't see that happening anytime soon with humans, but robotic missions, yes. We will probably continue to explore those various moons. And then as far as humans go, our moon again, we may return with humans to our moon. That's being talked about right now. With the current administration is thinking about how we might look at the moon differently. So we may send humans to the moon as a stepping stone to going to Mars. We'll just have to wait and see how that works out.
Awesome. And, you know, it kind of makes me think all that you were saying there, that it's as though the more we know, the more we realize we don't know, and the more we really want to learn and explore more. So questions breed new questions, and it's a never-ending cycle.
Yeah, it is. The more you learn, the more information you want.
Absolutely, and that's a healthy part of that love of learning and wanting to always know a little bit more. So
Yep.
So that's a great thing. So Doug, Trico Elementary is wondering, you mentioned something about habitability. Now, has NASA found any evidence of living organisms or past living organisms on Mars?
No, we have not. We have not sent instrumentation to Mars that can really do that yet. The Mars 2020 mission coming up does have an instrument that might be able to look at organic material in a little bit different light, that if there was biological organic material there, it might be able to detect it. But so far, we have seen no evidence of a living creature or fossil that we think could have been from a living creature on Mars. But we're looking.
Sounds good. Keep that search going. So from Vintage Magnet again in California, related to, again, human exploration, what do you do if someone gets sick during travel to Mars? Are precautions taken before flight? Do you deal with it just only during flight? How do you deal with that?
Yeah, great question. So there are two ways we would deal with that. First of all, we would think, okay, what are all the possible things that might go wrong? Maybe someone has a gallbladder problem. Maybe somebody has some sickness that will require surgery. So before you go, you think of what those things might be, and then you have a well-suited medical clinic, basically, that you're taking with you somehow on the spacecraft. It'll be small, but it'll compact, but you can at least have those things with you, medicines, for example. And then if the physician that's on board the crew, and there's almost certainly there will be one of the crew members that go to Mars has a medical background and has the capability to maybe do minor surgeries. You can't do huge, large surgery, of course, major surgery, but you might be able to do small surgery. And also we might be able to do it what we call by telemedicine, where we get the physicians that actually do the directing of the surgery from here on Earth. There are new technologies that we can do that, so potentially we could do that with a very well-trained surgeon here on Earth. So using what we call telemedicine could be another way.
That sounds like you'd really need some trained experts, and that's part of that teamwork, too, of people that are necessary to make things successful, both here now and as well as thinking into the future. It's always about a team. Now, Anasazi, who isn't on our line right now, but they had asked a question that I thought was quite interesting, and they're wondering if you could build an international space station sort of in Mars's orbit.
Yeah, that is actually being presented by one of the large aerospace corporations here in the United States as a possible solution to get humans to Mars quicker if we can't get to the surface because of cost mainly. It's going to cost a lot of money to put a large spacecraft on the surface and then have all that propulsion there to lift it off again to return to Earth. So there has been a idea that's been thrown out by this company that we build a international space station in Mars orbit, and we could do what we call telerobotic operations from there, just as I was talking about telemedicine, where we control the rovers real time from that particular station. One thing I did mention, and I saw some of the answers of some of the students, that time delay. It takes anywhere between when Earth and Mars are close together, 3 to 5 minutes to send a command there, to when it's on the other side of the sun, it takes over 25 minutes. So communication is going to be really tough, and you just cannot do what we call joystick a rover on the surface from Earth. So you have to send a bundled commands. However, if you are in Mars orbit, you could do that. You could actually drive a rover on the surface in real time.
Awesome. Now, Vintage Magnet 28, our group from California, and they're still on the line with us here, they are wondering about how do you deal with, whether it's, you know, let's think robotic exploration, how do you deal with serious setbacks, and have there been any setbacks like with our current rover on Mars? How do you deal with any of those setbacks? What's sort of the process?
Yeah, so we have setbacks with our rovers quite frequently. We're having an issue right now with our drill on Curiosity, and we are working on commanding the drill slightly differently so that we can use it again. And we're pretty confident we will figure that out. What it takes is workarounds. We always have an issue, and we learn how to work around it. Opportunity. Opportunity has a memory problem. When Opportunity goes to sleep at night, it just totally loses its memory. So anything that's in its cache, its mind, it's lost for the night. But we are able to reboot back up and say, okay, it's a new day, Opportunity, here's what you're going to do. And Opportunity says, okay, I don't remember who I was yesterday, but today I'm going to do this. And then they downlink all their data before they go to sleep again, and that's how we're operating on Opportunity. So challenges do happen that we do work around. Now, there was some pretty major issues with some spacecraft back in the late 1990s. We had two spacecraft that NASA sent to Mars that one did not successfully land, did not successfully enter into orbit in Mars and probably blew up. The other one was supposed to land on Mars and did not successfully land. It crashed. So we do have major catastrophic failures of spacecraft. That is part of exploration. It's risky. These do happen from time to time. So we try not to do that, but they do happen.
Yeah, and we certainly, I'm sure that lessons learned are things that always get reflected on so that repeat mistakes just don't occur. And that creative engineering aspect is certainly something that I think is really valuable, looking at things and how you can solve problems, whether it's spacecraft exploration or anything really in life. Finding creative ways to solve a particular problem of any sort is a really great skill.
Yep.
Now, Doug, I think I'm almost out of questions, but I have one more question here for you and the groups that are still on the line. Is there anything that you would say inspired you in particular, any event, any individual, anything that really sort of drove you and inspired you to do the work that you do today?
Yeah, there were two events in my life. Back when I was in 7th grade, I was pretty good in math, and I had a math teacher tell me that I was going to be a good engineer someday, and I didn't know what an engineer was. So I had to go look that up and ask my parents, and realized you had to go to college. So that was really inspired me. I thought, boy, I can actually do this. I can actually go to college. Little bitty town out in eastern Colorado, you can go to college. The other thing is that while I was growing up, the Apollo missions, when humans went to the moon, I lived through that, and that was incredible. I was glued to, we had black and white TV. I know that most of you that are still online don't even know what that is, but we had black and white TV, and we had to listen to most of what was going on the radio. That was our communication back then. But, oh, I loved it. I just loved the fact that humans were leaving Earth, traveling to the moon, and landing on that planet. And that was really inspiring to me. I thought, oh, I want to be a part of this so bad. So I think back in those early days is when I first started thinking that space exploration was a cool thing.
Awesome. Well, thank you so much for sharing that, Doug. And for those of you out there, every single student in every single room, whether you're on our live webinar right now or whether you're listening to the archive, if you are truly interested and want to do something in space exploration or really anything, you set your mind to it, you can certainly do it. And we know that some of you out there are going to be our next generation of scientists, explorers, and historians, and educators, and everything else that's needed that makes up of what we do here at NASA. So thank you for sharing, Doug, your inspiration. And for those of you out there, we hope you find your inspiration and someday join us here.
Yeah, and I do thank those of you still online for coming in and chatting with us today at the Johnson Space Center. I really do enjoy these opportunities to talk to students out there. So do good in school and strive for big goals.
I couldn't say it any better than that. Well, with that, it is just about half past the hour, and I didn't see any new questions come in, so hopefully I addressed all the questions that came in. So for those of you that are still on the line, thank you again for joining us, for taking some extra time out of your day so that you could learn about the journey to Mars. And thank you again, Doug, for spending your time with us today. We really, really are thankful and very appreciative of all your insight, your knowledge again, and your passion. So thank you, Doug, and thank you, everyone else.
Thanks, everybody. I appreciate it.
All right, until next time, we'll officially bring this to a close. Have a great day and have a great spring, and we'll talk with you again soon. Bye-bye, everyone.